Good morning, sir. This is Tausif. I am a computer science engineering student. Today, my topic is chain growth and step growth. We move on to the next slide. Chain growth polymerization. Chain growth polymerization. Monomers are multiple bonds without elimination of byproducts. Molecular weight of polymers has an integral multiple bonds without any elimination of byproducts. Next, introduction to the polymer chemistry. Large molecules, chain length, chemical structure, practical polymers are macromolecules, meaning they are composed of many repeating units called monomers. Chain length. The number of monomers in a polymer chain determines its molecular weight and physical properties. Chemical structure. The arrangement and bonding of monomers dictate the type of polymer and characteristics. Practical applications. Polymer play a crucial role in various industries from plastic and rubbers to fibers and adhesives. Next, chain growth polymerization. In the types of chain growth polymerization, it is one initiation, second propagation, third termination. Initiation. The process begins with the initiator that activates a monomer. Propagation. The active monomer reacts with more monomers, adding them to growing chain. Termination. The reaction stops when two growing chains combine or an active site is deactivated. Next, monomers and initiators. Monomers. Initiator, ethylene, it is a free radical. Styrene, anionic initiator. Methyl methacrylate, cationic initiators. These are the examples of chain growth polymerization. Propagation and termination reactions. Propagation. This is repeated addition of monomers to growing chain. Each step involves formation of new carbon bonds. Termination. Termination occurs when active chain ends or deactivated. This can happen through combination or disproportion. Living polymerization. Controlled growth. Living polymerization allows for controlled growth of chains with a minimal termination. Uniform chain lengths. This results in polymers with uniform chain lengths, a narrow molecular weight distribution. Block copolymers. Living polymerization allows for synthesis of block copolymers, which are polymers comprised of different monomer units. Step growth polymerization. Initiation. Two monomers reacts to form a Dimer, dimonomer. Propagation. Dimonomer reacts with monomers or other dimonomers to form large oligomer. Termination. The reaction continues until high molecular weight polymers are formed. Monomers and polycondensation. Biphenol, adipic acid, ethylene glycol, a key monomer for producing polycarbonate, a strong and transparent polymer. Adipic acid, a dicarboxylic acid that reacts with diamines to produce nylon, a synthesis fiber. Ethyl glycol, a diol used in a production of polyester, a widely used polymer. Kinetics and molecular weights of chain growth and step growth. Molecular weight distribution. Step growth polymerization typically leads to broad molecular weight distribution. Reaction kinetics. The rate of polymerization influenced by factors such as the temperature and presence of catalysts. Comparison of chain growth and step growth polymerization. Feature. Mechanism. Chain growth and step growth. Active chain and adds more monomer one at a time. Monomers or oligomers react to form larger chains. Molecular weight distribution, narrow distribution, broad distribution. Applications: polyethylene, polypropylene, polystyrene, nylon, polyester, polycarbonate. Thank you. Thank you for giving this opportunity.